our first session for
Recording is on.
yeah, thanks for the recording. This is our first session for presenting projects here at the office hours. We have seven people signed up today, so each doing 5 to 10 minutes of the presentation. Um, some last minute dropouts. We will go by the order in the issue in uh, GitHub. So um, here is the issue, and you can find your comment there if you signed up to present. In case there is somebody who needs to leave soon or anything like that, let me know. Um, we can move you ahead, but otherwise, Harsh is the first in the order here, and we'll start with Harsh. Yeah. So if everybody can see the screen, and if you're ready, feel free to take it away.
Yep. So first of all, like my screen is visible to everyone, right?
Yes, I believe so.
Yeah,
It works for me. Yeah.
hopefully. So yeah, let's just start the presentation. So this time in the Ethereum protocol fellowship 6, I'll be working on fast confirmation rule, and I am being mentored by Roberto from the Ethereum protocol consensus team. So first of all, like who am I? Like you guys must be knowing about me. I'm a permissioned fellow at EPF 6 right now, but just a brief about me. So I'm a undergraduate kid from India. I really like academically. I really enjoy distributed systems, cryptography, and machine learning, and I do a lot of open source work. Um, Before the Web3 kicked in inside me, I'm still a maintainer at Jenkins and a member of Istio, and I primarily work in infra right now when it comes to open source. And I got kicked into crypto when I was working on a core Bitcoin protocol at Fediment. And after that, I just started contributing to different open source repositories, primarily in Starkware explorations and Paradigm. And I was loving my time. So coincidentally, now I'm here and I'm really loving my time. You can go learn more about me through my website if you want to. But yeah, let's get a quick recap of what the Ethereum consensus protocol even is before we talk about the fast confirmation rule. So in brief, like the proof of stake consensus protocol right now consists of LMD Ghost and Casper FFG. And as you can see in the diagram, the chain is finalized by by the Casper FFG, where the branches are pruned out, and it simply becomes a linear chain. And after which the LMD Ghost operates and finally decides the head. So there are different technicalities in these things. Like LMD Ghost is a synchronous consensus protocol, and Casper is a partially synchronous. But we are not going to go to the technicalities of all these things. I'm just keeping it brief. If you want to know more, you can go through the link here and read about the whole proof of stake evolution that has happened. It's really interesting. So let's go to FCR. Like what is FCR, and like why should I even care about it? So it's a consensus layer algorithm for Ethereum that lets you finalize within 12 to 24 seconds, like it's just 1 to 2 slots, and that block will not be reverted. Instead of waiting for like 13, 20, in best case scenario, like 13 to 14 minutes for the full finality under Casper. So it enables the nodes to identify blocks which will not leave the canonical chain under good conditions. So that's a technical synchronous under good conditions by outputting whether the block is confirmed or not. And it has two fundamental properties of safety and monotonicity. So if the block is confirmed by the validator at a given time, it has to be a part of canonical chain, and that's the safe part about it. And once it is confirmed, it will remain confirmed for the future. That's the monotonicity. And assumingly, because nothing comes for free, like right, so we are not getting the full finality under the Casper FFG. So we are paying the price here. So the price is the assumption of network synchrony and Byzantine threshold. So network synchrony is that the votes are delivered by the end of the slot within the 8 second slot. And the Byzantine threshold is that the dishonest stake will not go above and beyond our assumptions of 1/3. So that was FCR in brief. If you want to learn more about it, which you should, you can go to the research paper that I've linked down here, and you'll enjoy it. And you might think like, why do I care? Like SSF is coming, like single slot finality is coming, right? But it's like long before we reach there. And in the meantime, fast confirmation rule is the way to go. And Ethereum community is pretty excited about it. There is a lot of things that we gain out of it. First of all, like users and dApps get near instant transfer confirmations for the small little transactions that we have, which improves the UX by a huge margin. Like you see in your wallet, like once you do a transaction, it is actually going to be backed by the consensus that that transaction is confirmed. And under the normal synchrony, it guarantees that the block remains on the canonical chain. Also, it reduces the risk trade reversals for exchanges that allow optimistic trade upon deposits. Also, it is useful for uh, PBS as it provides block builders with an indication of whether blocks that are building upon is likely to be reorged or not. So it is actually a very aha moment. You guys must be getting some aha moment. Oh, this is actually very, very useful, like very helpful. And that's why I think it's very important for us to for us to implement this in clients that we already have, the consensus clients. So yes, it is very important, but what is the current status of this thing? Okay, that's quite complicated. The first original FCR that got out by Roberto and other authors, Circle tried to implement it, but not exactly in a client. They tried to benchmark this stuff, and they did a very, very good job in that. So there is a blog post which I've linked later in the slides, which you can take a look at, and that gave us a very optimistic um, outlook on the FCR. But they did some not I would not say mistakes, but say left out some major part of implementing FCR, which does not give us the complete view. Now after that, Prism also tried to do this, and it's still in its early stages, but it has given us a very good glance on how it is working when implemented in a client directly. They have combined like LMD Ghost and FFG checkpoint votes, but the problem is even with the Prism, they have not done it completely because it's very complex. When we introduce FFG checkpointing votes, counting that is kind of complex in when implemented in any client. And another thing is that the specs are now changing. So they're trying to make the code logic more simplified. They're trying to enhance the story structures for the track confirmation routes and checkpoints. And cross epochs are being handled now more better. The proposer boosts are being handled nicely. So there are a lot of things that are changing. So the new spec hasn't been implemented in any client whatsoever till now. Apart from Prism, no other client has worked on it till yet. Teku is going to work on it as per my knowledge, but not now. So I think it's time for other clients to join the band, and I am going to work on Lighthouse so that they can get a new look on what is going to happen when they try to implement FCR in it. Now, this is where things get interesting. What I am going to do in the fellowship. So during the fellowship, I will trying to implement the new FCR spec from scratch in Lighthouse. And Lighthouse has a very interesting technical architecture compared to other clients where it uses tree states or fast state access. Now, this is a very technically complex thing, so I can't talk about it here. But if you want to learn a bit more about how am I going to proceed with this, you can go and take a look at my proposal that I've linked down there. And the vision of this project is to create and benchmark a performant version of the research prototype of the fast confirmation rule. And I am going to include the FFG Casper with the LMD Ghost, and it would be a more complete implementation of the FCR. It's going to be pretty hard for sure because nobody else has done it yet. And managing those checkpoints and votes is slightly complex when it comes to clients, high performing clients like Lighthouse. So it will have like full FFG and LMD Ghost integration for the true safety. And we'll have lazy FFG support for the head votes because we don't want to scan the full attestations. And I'll try to make it reorg safe as well. So hopefully the aim of the work is to create a strong foundation for future work to happen when we start to adopt FCR in production environment. Okay, so this is what I'm going to do. Now you might get interested. So if you are more interested in reading about all these things, I've linked a lot of stuff. These are very detailed things. Just go and read and you'll have a lot of fun. Yeah, thank you. If you have any questions, you can ask out. That's the right time.
You are right on time, right on the minute. So thank you so much for that.
Yep.
Anyone has any comments, questions?
Curious?
Yeah, yeah. You can
Like
try
if
to.
you are curious about it,
Yeah.
you can just simply go through the resources that I've shared, they are very comprehensive. And if you want to take a shorter look, you can go to the draft proposal that I have, even though that's sort of technically complex. But if you're good, you can take a look at this and you can ask me questions in my DM and on Discord or mail me or whatever you want to do.
Just a quick reminder to please share all your slides in the Discord.
Absolutely, yeah. So my slides
The
will be on Discord, and it will also be linked in my proposal most probably when I make a PR on GitHub. So don't worry about that.
Yeah, great. It's just can be challenging to see the slides
Yeah,
over Jitsi. They get a little
yeah, I
blurry
understand.
sometimes.
So any
Yeah.
question, guys?
This is still using the safe block hash on the engine API, or is there a new design there as well?
That's actually a very good question. So the UX is not. We haven't decided on whether what should be doing, what we should be doing to expose this by the engine API or by some other means. So this is actually a research prototype. We haven't gone that far to decide about this thing. Like there are genuine concerns. Do we want people to set their own Byzantine threshold beta value? Because the problem is once the beta value exceeds a certain limit, the mathematical equation will start falling apart. So we don't want that. But we haven't really thought about what the UX is going to be directly. So unfortunately, I can't exactly give you a concrete answer on this.
Okay.
Okay, thank you, Ethan, and yeah, thanks for the presentation, Harsh. It was great. Very well. Next, we have actually three people who decided to postpone their presentation after they commented. So, Sharik, Odinson, and Vinit, if you are here, just wanting to confirm that you are not presenting now. Um, Unless you want to present now, let me know. Otherwise, we will move to Utsav. Yeah, I'm not sure if we can hear you.
So,
Yeah,
are you waiting for them or should I start it?
please share your slides, share your screen, uh, share
Yeah.
slides, and then you can get started. Yeah, awesome.
Is it visible?
Yeah, perfect. You can
All
go
right,
ahead.
cool. So, yeah, my name is Utsav and I'll be pursuing the project benchmarking GKVMs on names beacon state transition functions during this cohort. And I'll be working with Dimitris, who I guess is in the call as well. And he had presented it in Cannes as well about this project. And I tried to make the presentation a little different from what has already been discussed during Cannes. So yeah, our winter is or not during this project. Let's just begin. So Justin Drake proposed the beam chain in December last year during DevCon, and the main goal is to replace the current beacon chain with the new beam chain uh, due to the risk of quantum attacks, and we need to make it. We need to Starkify the beacon chain as well, so that all the nodes, then all the consensus clients, nodes running the consensus clients don't need to execute those functions themselves, and they could be executed on the proven networks, so that the main goal of live clients and consensus nodes would be just to verify those proofs and check that the functions are executed correctly or not. So let's just move forward. And yeah, these are the key features. I guess most of us know about Beam Chain. It will give us improved security. That's the main goal. Focusing on hash-based signatures or Falcon signatures, and we'll try to snarkify. So, snarkifying, some of you may not have heard of that term. So basically, what we want is to compute our state transition functions inside a virtual machine instead of clients running it themselves. So, and the current state is that proofs can't be generated inside, say, a MacBook or any laptop because it's just very computationally expensive. So we need to modify the beacon state and next the beam state to make the functions executable, and that's what snarkifying the consensus is. So by offloading all the computations to the ZKVMs, it will be actually an off-chain execution and on-chain verification of those. And of course, this would reduce the burdens. So the goal is that just like peer does, the proofs would be stored on data layer and it would be pruned, say, after 14, 15 days. And instead, verification would be done by the nodes themselves. Yes, the challenges are that there exist a lot of ZKVMs in current ecosystem, and more are coming. Recently, Cisco announced similarly, and most of them are using RISC-V architecture. Some of them are using a different architecture, their own architecture. So it's very difficult to say which ZKVM should we prefer, and every one of them gives a different performance, and the benchmarks are really not clear right now. Some of them are not exactly benchmarks to say, they are just doing benchmarks on Fibonacci or say SHA-256 and not on Ethereum itself. So that, and the code base should again be modular so that the prover can choose on which ZKVM he or she needs to compute it. And so let's discuss now about state transition functions. Basically, uh, a block would be the operation input, and it will be executed on the current beacon state, and we'll get the new beacon state. And this whole process needs to be done off chain because it takes a lot of computation. Mainly all these operations, validation, attestation, slashing, state sync committee updates, these all take a lot of compute and they can't be done by every node on every laptop and mobile in future. So let's just discuss how the STF is implemented. It's basically a it's a wrapper of three functions. The first one is process logs. The second one is verify block signature, and the third one is process logs. So process logs is again a wrapper of process log and process epoch. And then process epoch is just a wrapper of all these functions given here. Uh, and then there comes a process log, which is a wrapper of all these functions. Out of these, one or two needs the execution layer's involvement as well, such as this one, consolidation request and BLS2 execution chain. Uh, so the main problems are DLS signature verification. It's very heavy, and Merkle tree updates, which almost takes 90% of the time when I was checking the benchmarks and you seeing the flame graphs. And I don't think we need to worry about BLS signature verification because in the beam chain, it will probably be replaced by Falcon signatures or hash signatures, and they are a little less heavier than these. And other than that, yeah, it's memory intensive. So we can't just give the entire beacon state to the ZKVM. We have to give the state root, and then we have to give the Merkle path along with this. And all the state tree traversal is a little memory intensive as well. So these are the things we have to consider while choosing which ZKVM to use and how to modify the state transition functions. Now, let's discuss about ZKVMs as well. I'll go quick about this. So what we need to do is verify that the computation is correct, and that's what ZKVM does. So it will take the pre-state root and it will take the block, which validator attestations and validator operations and every other operations, and it will give the post-state root. And so this whole process will be done off-chain, and this verification will be done by the beacon node or beam node itself. So they'll just check that the output which was given and the pre-state and block which was given along with the proof when they are passed that this verification works. And yes, beacon chain GKVMs need to be complete. That is, if state transition function is executed correctly, everything is correct, then proof will be valid. And fraud proofs can't be made That is the computation. We can't produce a beacon state that is not matching with the operation, log operation, and the intermediate states need not be revealed. They should not be revealed, which is the zero knowledge property. And the most important thing is succinctness. Proofs should be small and they should be really fast to verify because that's the end goal. We need to achieve single slot final identity. Everything should be done within 12 seconds. And okay, so yeah, I was trying to work around just getting an overview of the current GKVM landscape and came to reach this conclusion. So I've already worked with SP1, Resiro, and Jolt. So I know a lot about them. And I was reading Starks as well lately a lot. So I know the underlying architecture of Resiro as well. So and the benchmarks have already been performed on SP1, Resiro, and Jolt. The first two by the Ream team itself, and Jolt I have performed it myself. Other than that, these are the ZKVMs which need to be studied more and worked on them. The newest one in it is ZK Sync Airbender, and I find it has a lot of potential. However, since the documentation is still incomplete, I'll wait a week or two before I start on that. Okay, so now let's discuss what exactly needs to be snarkified. This is the Ream crate, which we discussed, that state transition functions, slot processing, everything is over here. And these are the crates involved, tree hash, SHA2, VLS signature. Tree hash is the one which by which we compute the state root of the beacon chain. And it takes really a lot of time. Here it is. It almost takes 80% of the time when run on Beam. This is the benchmark. This is the flame graph I ran when I was benchmarking the race zero, executing those functions. And we can clearly see Merkle really takes a lot of time. And SHA 256 takes little less time, and PLS signature also take a lot of time. And this is the architecture of consent zero. I think Demetrius had gone over this in the can, so I'll just keep it. This is the architecture that's planned now. It's really difficult and it will definitely undergo several changes because I don't think it will be possible to just create a trait which can be used by every ZKVM because they are really running differently. Everything is being done differently unless they themselves change their architecture, which is really not possible. So the idea is that we can keep all the ZKVMs in the runners and the trait common functions traits will be here and orchestrator will be used to benchmark those. And this is the Ream crate where the Ream crate will be placed and the snarkified STF. And this is just benchmarking cycle risk by cycle tracker or any other ISA cycle tracker. And yeah, these will be exported. So basically, the prover should be able to just run it through CLI and choose whichever ZKVM backend he or she needs to use, and proof must be generated. And they can share that proof to Node or whatever needs to be done, and they can easily verify it. All right. So yeah, RIS0 and SP1, the Ream team has already benchmarked all these functions, attestation, attested. Most of them are process operations, and this is from the process block. And I had talked with Onod, and he thinks that we should next be doing process slot and process epoch. The problem is that some of them really are very don't need anything, so they can be run on chain as well. So they really need not be snarkified right now. And some of them will undergo heavy changes, like process BLS to execution chain or random because BLS will be entirely replaced in the beam chain. We'll just have to wait for beam specs until then. Yeah, so we had already discussed this. Yeah, so until yes, I was making this PPT yesterday, and until then, I couldn't find a workaround around this, and I was stuck at Jolt till yesterday. So basically, they don't allow, they have their own constraints that input can't exceed this size, and the execution can't exceed this size. So the guest eventually panicked, and so I was talking to Michael, who is Joel's maintainer. So we both could fix it after some changes, troubleshooting it. And I am not checked the benchmarks in detail, but they look faster to me than SP1 and 0. Maybe it's something good for us. But the problem with Jolt is proof aggregation is not possible. So we wouldn't be able to make, uh, I mean, Snarkify won't really work on Jolt a lot. But if the execution is really fast, it will be great. So the priorities are we can either just, yeah, all right, I'll just yeah, just 2 or 3 more slides. So we can wait until Beam gives a spec, and meanwhile we can just focus on which ISA is best for uh, benchmarking ZKVMs. Most of them are on ZK RISC-V, and some of them use their custom CPUs. And this is the main thing we talked to Not, and he said a centralized documentation would really be good, which tracks all the GKVM's comparisons, and we could list all the performance issues they were facing so that the state transition functions could be modified accordingly. And so I was working on Jolt integration, and soon I will be working on Pico integration. Meanwhile, Dimitris is working on OpenVM integration. The plan is to work on 809 ZKVMs to find patterns on what we can do, how to make it better, and find proof aggregation strategies, recursive proving, and finding pre-compiles for cryptographic primitives that do not diminish security and would give us good results. And another problem with SSH serialization, I think we'd have to directly modify the Ethereum SSD library to make those changes. And the eventual goal is to make a comparison matrix and give performance recommendations, how to boost performance, GPU acceleration, and of course, the strategies would be optimized for each GKVM. We can't just propose a single solution for all of them. And yes, there should be an integration guide and proper documentation as well for anyone to come and prove using the proven networks. That's it for now. These are all the resources. And if anyone asks a question, I would love to answer that. All right.
Have you thought about continuation support? Like in the modern Zika VMs, I think they should be there, but for the state transition function, it can break. It will help in horizontal scaling, right? Because multiple provers can work on a single segment for the computation in parallel. So it
You
should
mean
reduce
proof
the overall.
aggregation, right?
Yeah,
Yeah, that's something not every ZKVM supports. Right now, only 8
yeah.
or 10 ZKVM support that. And that too, it's very limited. RISC-0 has a very, RISC-0 and SP1 both have a really good documentation about that. And ZISC was right now announced and they boast of proof aggregation. So that's something that's really needed, recursive proving and proof aggregation. And we are working on that right now. And I guess that will help a lot.
Like not only proof aggregation but also the parallelization. Like we want to proof in parallel, so there is something
Yeah,
called continuation as well. So maybe it's not exactly proof aggregation.
you mean like parallel proving, right?
Yeah,
Distributing the work in GPUs. I
yeah,
guess
exactly.
that's something each proofs is doing right now, executing
Okay.
blocks over GPU clusters.
Hmm.
And they are doing it for the execution layer. But I think it should be possible for us as well.
Okay.
Maybe because right now the current focus is to mainly change the state transition functions according
Hmm.
to proof aggregation and how it should be fitted to ZKVMs. I think all this like parallel proving can be achieved later as well. So
Okay,
I
that
don't
does
think
that
it's
does,
the current focus of Beam.
yeah, that does make sense. And uh about the architecture as well, like I think RISC-V is like the most celebrated one, but there are others as well, like MIPS and something. And I think OpenVM has like no
Yeah,
CPU architecture of some sort. So
OpenVM
like
has
how
a
are we?
really
Yeah. So
exciting
how are you?
architecture. Yeah.
because it is a modular architecture that they're trying to use. So how are you choosing between them? So maybe you will benchmark all these zk VMs in the project and then you'll pick and choose, or how are you
Yeah.
going about this?
The initial step is just to create a comparison matrix and benchmark literally all the ZKVMs, running the
Wow.
SKS on all of them. And then maybe coming to a conclusion. I don't think we can still conclude, but maybe
Yeah.
just get to know more which ISA is better. OpenVM really has an exciting architecture. We can literally make any ZKVM of our own as well through that. And that would be really interesting to work on. It's the next in line we'll be working on after Jolta and Valida. And
Absolutely. That
Valida
does make
has also announced proof aggregation themselves, so we'll be working
sense.
on that as well.
Yep. Great. Yep. Thanks for the answering my
Yeah,
questions.
nice question, Valida.
Yes, one second. So, can you see my screen? Yeah. So, we are working on the block level access list implementation in Red. So, in Ethereum, most of the blocks can be parallelized. So, over 60 to 80% of the transactions have shallow dependency chains are somewhat independent of each other. Now, of course, there are some level of the blocks which have a high degree of the entanglement or the long dependency chains, but their numbers are quite few. And keeping in mind the entire transaction execution can be done in a parallel way. So an initial effort was back in EIP 2930, which aimed at creation of the access list, but I believe since it was kind of optional, it reduced its effectiveness. EIP 7928, or likely we call it block level access list, we is aim at causing the transaction to be executed parallelly by enabling the storage of the storage locations and the transaction level state drifts. Now we can think of it something of like a state transition function like the apply bal, which would take your pre-state and the bal as an input and provide the post states as an output. The clients are somewhat prepared since they already use optimistic parallelizations, which I believe is kind of helpful when the dependency change out of average size, but it fails when they have a long dependency attached to them. Not only that, it is kind of helpful in case of your zkEVM context as well, since it would enable for the proving verification to be takes place without actually executing them. And in case of stateless uh, partially stateful client as well, which only have to maintain a subset of the state, so it can easily do that without actually caring about the rest. And it is helpful in case of your reorgs and these things, since it can update the states in that. Now this is somewhat a very brief overview of how exactly we thought of it to be helpful, but there is much more to it, and I believe that anyone who will read the EIP and the associated talk of it will find out. Now, coming to the implementation part, as per the EIP, which I believe is a continuous revolving state, it will involve change to that of the block structure, that in your block header and the block body. Now, the block header would have something like the bal hash, which is the bytes 32 field, and the block body would have the block level access list. Now, it's not just a simple structure, but it is more, there is much more to it, since it delves in a quite a depth, and I believe Shobhil will give a better overview of it. But all in all, I can say the kind of the changes this CIP wants from us is kind of not backward compatible and will require hard fork.
Hello, can you hear me? So the block access list, to implement block access list, we need to introduce several structures. The block access list is kind of a list of account changes, and an account change is the state difference for a particular account. It has several components such as slot read, which store which slot has been read in a transaction. The slot changes, which is further composed of storage changes. It tracks the storage slots that has been written and also the new value. The code changes tracks the code change, nonce change, and balance change. Traces the traces the states. These compo these these are collected together to form the block access list. To properly implement the block access list, we must also change the state transition function in a state transition function. We need to track the pre-state because it is needed for comparison. Then we also need to trace the storage change, nonce change, and other state difference for every transaction in the block based on the various conditions given in the EIP, such as what happens if the value is not changed actually. I mean, the new value is previous same as the previous value, and also for the zero balance transfer, there are also different edge cases we have to consider. After the recording, we need to actually assemble the block level access list. Then we'll use it to validate the block data, and probably next it will help us to parallelize the transactions. We have created a rough roadmap. I am saying it rough as the EIP is constantly evolving, and as per the Discord discussion, there are several more changes to be made. So at first, we will make the structural changes of the block in Wraith, which is located in the alloy. So we have already done some part of it, and the next we'll try to implement the corresponding tracers. I believe the REVM inspectors provide the great tracing API for Wraith, and currently right now we are working on the storage tracing. But we believe that in a couple of weeks we'll be done with the tracing part, and we'll go into the next part, which is constructing the actual block level access list. After that, we'll test our implementation of the tracers and ask for review from our mentor, and if modification is needed, we'll modify. And meanwhile, if the specs changes, we'll have to take in account that too. And after all that, we'll use the block level execution list to block level access list to parallelize the transaction and benchmark our result. In our project currently working is me and Isika, also known as Rhyme, and our mentor is Messi from Red. Thank you. If you have any question, you can ask us.
Maybe just some explanation about 2930, which is like the current access list in the transactions. And yeah, they are essentially not used for acceleration anymore because like originally this was introduced for, I think, like to match the Geth database more closely, but they have since switched their database design to this path-based storage. And now the only reason why this feature is still sometimes used is because there have been a couple gas repricings. And if you have funds on some random smart contract that doesn't work well with the repricing, you can kind of abuse this access list mechanism to lower the cost to access that storage slots from that contract and still unstuck your funds. But there is not really any reason to use that feature anymore because, as you correctly pointed out, it's optional, it is not reliable, it can have extra entries, it can have missing entries. So, yeah.
We have gone through the IP, and that's exactly what we found out. Like, we just had a sharp contrast of when working the 7928 and while studying the 2930. Well, I believe that after like going a bit more in delving deep, I believe that it will be much more helpful for us to formulate exactly how this will stand out compared to that.
Yeah, I mean this new one doesn't change the gas pricing, I guess. It's just to serve as a hint for other ELs to execute the block faster.
Yes, yes, absolutely. Thank you.
Yeah, sounds good. Did the link share, or I think Jitsi chat's being a little weird. I tried the, yeah, I sent it in chat. There it goes. Okay.
Go ahead and post it in Discord as well, because I
Okay.
think, yeah, Jitsi chat is
Yeah.
not working real well.
All right. Let me throw that there. All right. You can all see my screen just fine. Perfect. All right. Hi, everyone. My name's Pella. I'm I'll be a third year CS student at CU Boulder this fall. Currently, I'm interning at Microsoft doing some like Rust hardware security stuff. And today I'm going to tell you about my project, a RETH implementation of Fossil. So real quick, I know it's been a couple projects already, I think at least 3 or so that are doing Fossil implementations. So I'll keep the explanation pretty quick and try not to bore you guys with the details. But what is Fossil? Fossil, we're going to add inclusion list, which is just a new data type of a list of signed transactions. We're going to add the inclusion list committees, which are just randomly assigned validators that propose those inclusion lists. And then we need to enforce those inclusion lists. This enforcement part is still a little murky on the best way to do it, but essentially it's ensuring that new blocks are only valid and only attested to if they include a certain amount of transactions or fill any empty block space with those transactions. And this is all in an effort to help reduce censorship, as right now I think it's like 80% or probably even more since the last time I checked the numbers of blocks are built by these large, sophisticated, centralized block builders who have been shown in the past to be censoring OFAC transactions and other things that states have sanctioned. So this is all in hopes that we can help make Ethereum more neutral, more credibly neutral, and and more censorship resistance. Resistant. Um, Getting into it real quick, as you can see on this graph, it's showing the progress of other execution layer clients. And Rest Bar is pretty far out there, but this is also based on the work that was done about 5 months ago, and it hasn't really changed much. And this was all done by Jacob Kaufman, who has since stopped working on it 4 months ago or so. And I talked to him, and he said I was good to take over the work. Um, what has been done so far is a basic implementation RETH. Um, it was based on the assumption that would be included in prog. So that's one thing that needs to be updated, and rebasing it on top of the prog changes and other updates of RETH. And then also, but sorry, I'm getting ahead of myself. He, in his fork, has a basic implementation that was able to do some best case scenario interop testing, but was still failing a lot of other stuff from what I was able to grasp from the meeting notes. So what's left to do is that rebasing I was talking about, which I've already started and is proving to be a little bit more difficult than I thought, just because RETH has been, the insides have been rearranged quite a bit. So working through that, and then also updating any changes to the spec. There's only a few pretty small things right now, so hopefully nothing major changes. and then also helping contribute to the execution spec tests that are in the works right now, and just general testing both in RETH unit and interop tests, and also interop tests with other clients through kurtosis and other means. And then last but not least, different implementations of Git inclusion lists. The spec doesn't specify this on purpose, and that's to give clients more freedom to decide how they build their inclusion lists. So right now, I believe it's just taking the highest fees, throwing in an inclusion list, and calling it good. But you can see more complicated schemes that maybe look how long transactions have been in the mempool to try to help with that censorship resistance part. So maybe making that modular or just changing it out for something else, still up in there. So final deliverables, what I'm going to be aiming for is just create a REST client that is able to effectively participate in local interop testing. So just get it up and running, finish the rebase, fix all the issues that I'm able to in the time, and try to make the most battle-tested REST client that I can. And then a stretch goal would be having it ready for more public dev nets, but this is also dependent on what the core developer schedule looks like, if Fusaka gets delayed, if Fossil even makes it into Amsterdam. So just trying to push RETH as far as I can with this EIP. And then there's no official mentor for this project because it isn't really an official project, but RETH has a very good, strong open source community. Some of my first open source commits have been to RETH, and everyone's been more helpful than anywhere else I've been on the internet. So I'm not too worried about that. With that said, I'm still very open to a mentor if Mario or Josh wants to throw something together, but not a big worry of mine. And then with that said, I'll give you guys back some time. Follow me everywhere, Pellcrab, Telegram, Discord, Twitter, pellcrab.com, etc. But yeah, any questions? That sounds great.
I think Paradigm is really, really good when it comes to like helping open source contributors. So you might just be able to work without a mentor as well. They're just way too good, god tier.
Yeah, top tier. I've met a couple of them in person, and they're all just amazingly smart people. Cool.
I don't see them in the list of participants.
Yeah, sorry, I just saw a message on Discord by Vadan. He mentioned that you know that. So yeah, he mentioned that.
Yeah, like in general, what's the best way how you recommend we organize it? Should we have like a separate call or should we do this as part of this one? Yeah, I mean,